A few weeks ago, Mr. Pete posted a two-part video where he shows us how you can make a hammer on the shaper. Now it's a really interesting video, and I think if you haven't seen it, maybe go and have a look. There's a link to his video in the description below this screen thing here. Now we're talking about a typical school project, just like this one. This is the hammer I made when I was in school. It's a long time ago. And his video is stuffed with useful tips and safety warnings, and I think that is a really good thing. Now, of course, Mr. Pete, he's a professional explainer and I'm just an amateur. But where I had a little bit a personal difficulty is when he tells us that shapers are slow, and he repeats that a few times. Sometimes shapers are slow and sometimes they're absolutely not slow. To illustrate that, I'm gonna make exact the same hammer as Mr. Pete made, but I'm gonna do it my way. I'm not telling you it's the way to do it, it's just my way of doing things. I have here an ugly thing. I'm gonna cut a piece off, and this ugly thing we're gonna turn it in a beautiful hammer on the shaper. But before we start talking hammers, first we're gonna talk a bit about the shear tool. In a previous video, maybe you remember, I worked this surface with the shear tool, and in the comments there were a few questions about the shear tool, and some people asked me if I wanted to explain a bit on the blackboard. Of course, let's do. I did a little bit of my homework here. This is one page of a shaper book. Of course, I'm not gonna print out the whole book. One page is enough. And the shear tool is marked here. It's the only book I could find that talks about the shear tool. Now the question was about angles. All the other tools, the angles are marked. On the shear tool, the angles are not marked. So here we are a bit on our own. Okay, let's take this paper away, don't need anymore. This shear tool, and I'm gonna make it bigger on the blackboard. This is the front view. The tool is gonna cut out of the blackboard into the camera. Side view, the cutting action is that way. And here we're gonna make the bottom view, held like this. Okay, front view, what do we see? It's a bit hard to draw, of course, because it's 3D. This is the part that I'm gonna take away. Will be a bit easier to see. And then the bottom view is like this, and the side view rounded like this. Okay, now this face is of course this face, and the angle I made between this face and the vertical is 3 degrees. The radius is as big as possible. It must be, I think, about a radius no, radius is a little off, of course, of 100 millimeters is about 4 inch. Yeah. This angle, I made it at 70 degrees, and in the book I showed you they talk about 75. Okay, it's 15 in the other way, but 70, 75, that will do. I think the shear tool is one of the most challenging tools to make, because you use these numbers and sometimes it works and sometimes it doesn't. So I think it's important to make one, experiment a little bit with it. In one book I found online, they talked about this angle. The face is angled at 45 degrees. That's not enough, that doesn't work. I made it here 45 degrees. I don't know if you can make it out a little bit. This one not good. This one much better. And this one, of course, I'm gonna try to mark it here. Somewhere between 2 and 4 degrees will do. Not too much. It's better to make it 2 degrees than 4 degrees, otherwise it wants to dig in too much in the material. So I hope all this make a little bit sense now. If not, don't be afraid to ask questions, and we'll see what we can do. Of course, I cannot answer all questions. I'm not a specialist, but I try and I experiment and then I see what happens. Okay, enough talking about shear tools. Let's talk hammers, because in the meanwhile my other myself prepared the blank with the outlines on it, and let's go for it. To install the workpiece of the part on the shaper table, this time I'm not gonna use special setups and scrap metal fixing things. This time I'm gonna use a vise. Now, if we put the vise on the table, we can put it this way, or 90 degrees this way. You're gonna tell me what's the difference. I'm gonna take apart. I take this bigger thing, it's easier to see on camera. Can put the part in this way and cut in that direction, of course, or put my vise this way and cut in the length. Let's go back to the blackboard and see what's the difference. Having a little blackboard as this one in your workshop, in fact, is really handy, because I make my drawings and my sketches on this, and wherever I am in the workshop I can see it. So no need of glasses to watch this little paperwork and then maybe I can find this paper anymore. And in fact, this one is not even a real blackboard. It's a part of a dishwasher painted black. Here you go. Okay, a little bit of theory. This was the part I showed you. Of course, I'm not gonna work this one, but this is easier to see. I'm gonna work this face, yeah? And this face measures 120 or 20. This is in millimeters, but you will see that in inches it's exactly the same, and you will quickly understand the difference. This surface I'm gonna cut this way, yeah? The tool is moving that way. We're gonna use a step over, this is for a roughing, of 0.2 millimeters per stroke. The machine is running at 100 strokes a minute. Take a magnet here. Voilà. What was I telling? The part is 20. We leave, of course, 15 before the cut, 5 after the cut, makes 40. If I put my machine on maximum, 160 strokes a minute, we have a cutting speed of 10 meters a minute. Not enough. Be honest with yourself, almost no one changes the speed on its shaper. So this one is now set at 100 strokes a minute. 100 for a stroke length of 40 is somewhere between 6 and 7 meters a minute. You will never have a good finish with 7 meters a minute. Let's continue. Step over of 0,2. So when we start cutting here, we do all the surface. 120 millimeter gives us a total of 600 strokes before the whole surface is cut. This surface we're gonna cut in the other direction. So we put the vise 90 degrees, of course. Step over, same. 0.2. That gives us a total number of strokes to cut the whole surface of 100 strokes. 600 strokes at 100 per minute gonna take us 6 minutes. 100 strokes at 100 a minute is, of course, 1 minute. Here shapers are slow. Here shapers are not slow. It depends how you use it. Let's say for a special project I have to make, I need to cut a surface like this one, which is 1 millimeter. Yeah, 100. If we cut this way, and it's a finishing pass, so we're gonna use a step over of 1/10, 100 millimeter divided by 1/10 gives us 1000 strokes. At 100 strokes a minute, this is gonna take us 10 minutes to cut this way. We're gonna cut it the other way, like this. Step over 0.1, 1 millimeter with a step over of 0.1. This surface will be cut in 10 strokes, which means 6 seconds and game over. Shapers are slow. Shapers are not slow. We're gonna cut in the length. The chip has to break. If I don't make these notches, the chip will not break, it will stay on. Now, Mr. Pete, he did put his work like this in the vise. I'm gonna do the same. Like this, and then put it at 45 degrees with his half square, a bit like this. It's a little bit fiddling around. Now, there's nothing wrong with this system, but I prefer using a V-block because I have this corners here. I took the burrs off, and you're not really sure if these lines are effective parallel to each other. And now the work is held just on 2 very thin lines. it could maybe a little bit damage the jaws, because this is a very cheap vise and you never know if it's hard enough or not. So I prefer use a V-block. Now Mr. Pete, he talked also about a V-block, but he couldn't find one. For me it's worse, I don't have one. So first I'm gonna make a V-block. Now I have a V-block. It's a nice little project for a Sunday afternoon, making a V-block. That's fun. Now we put the V-block, of course, always, if we can, against the fixed jaw, because the moving jaw is moving. You're never sure if you have this 45 degrees. Right, I can cut two faces in one setup. First I will cut this one, and after I will cut this one in one setup. So I have to flip the part only one time. But I'm gonna show you also another way. We're gonna put the part horizontal in the bottom of the vise and put the cutting tool at 45 degrees. So we can cut one angle at 45 degrees, flip the part, cut the other one. That's the plan. I'll do a little finishing pass. I gave a bit too much angle on the cutting tool. The bottom side is rubbing on the surface. And that's okay, it's the principle that counts. Right, one is done. Finishing pass. Right, two sides are done. Before we continue, maybe just a little tip. This bizarre looking thing here is my cutting tool with the round nose, and I made on purpose a very nice and big radius on the nose. If we're gonna cut a vertical surface and we wanna set the machine at 0, we're gonna touch off with the cutting tool like this, set the 0, dial in and then we make the cut from top to bottom, no problem, it will be precise. Horizontal surface, same story, we're gonna touch off with the cutting tool, set the dial at 0 first, dial in what we need, we cut the whole surface, no problem. The touch point on the cutting tool will be here for the horizontal surface and will be here for the vertical surface. If you want to cut a V-block like this one, or for the hammer, for these flats is about the same story, we have to touch off on a surface in an angle. Now in this case it's 45 degrees, but whatever angle is always a bit a problem. So the tool, we're gonna make it touch off right here, dial in what we need, and the finished surface will come here. Too low, because the rounding of the nose, this is the horizontal touch surface. Yeah? Here is the vertical touch surface. So the 45 degrees should be here, but here is nothing. We touch off here, and this distance between the exact 0 and the radius of the tool will be the distance you have cut too much. So be aware of that. Done. I set the stroke length on maximum. Not a problem. And then of course I put my part in line with the cutting tool. Go! Finished. I think it doesn't look too bad, and it was quickly finished. Now of course the reason why I cut first these features and not the point, if I cut first the point I lose all this gripping surface. I will be left with only a little surface to clamp on with the vise. So first we do these little features and we still have these flats to clamp on with the vise when we put it the other way. This one is 18, so it's gonna give me 90 strokes to cut. 90 in one direction, 250 in the other direction. So 90, it will be a bit less than 1 minute cutting. To put the part in place, we're gonna do the same what Mr. Pete did. Take a ruler, this is the other half of my square. Put it here on this fixed jaw. Fixed jaw is always better than the moving jaw. If we put it that way, if the tool grips the part, it's gonna grip absolutely here at the beginning of the part, which means it's gonna push out but also lift up, and that can be a serious crash. So that's why I prefer put it this way. I can hardly see the line, but that will be okay. And always be careful with these cutting tools, because cutting tools are very good in steel, and I learned the hard way that they are also very good in fingers. So be carefully. I'll take my hammer. That will do. To make it easy to set the zeros, I move the cutting tool just above the line and then come down until the cutting tool is scratching the line we made previously. And this is where I set my zero. You can set the zero touching this edge here, but who knows how deep we have to cut. Now we know we have to cut until we reach the zero. Now we can move the cutting tool to the front, bring it up, that's a bit too much, that's okay. Voila. And now we can dial in, for example, 1 millimeter. This is my finishing pass. The tool slide is at 0, the diamond is at 0, and I see that I touch exactly the line where it should be. That's good. That looks good. Okay, I'm gonna deburr it a bit and do the other side off camera, because I suppose you've got the point, the point. I think the finish is decent for a roughing tool. There's not really a problem. You still see the lines and the outlines I made here for to see where I have to cut, and then the file marks are a little bit too deep, so I had to cut this a little bit deeper to be good, but I can give it a touch with a file or on the belt sander. Now, if we're talking machines, I think it's important to compare what can be compared. This is a small shaper. Compared to a milling machine, it should be a small benchtop milling machine, right? If I have a big shaper, it could be like the typical milling machines we see in machine shops, these nice big milling machines. Now, if I make this part that I already showed you, this surface, in the shaper I took off 2/10 of a millimeter in 3 passes. So this took a really long time. I didn't time it, but it takes a long time. Do this in a nice big milling machine with a fly cutter, you dial in 2/10 and in no time this surface is finished and we don't touch anymore. Shapers are slow. If I do these corners on my brand new hammer here, do this on a milling machine, you can put your hammer this way in the vise and you can do 2 phases. I think the setup you need to put on the vise and the tool, the setup of the machine is almost, or I suppose, a bit the same for a shaper or for a milling machine. So, milling machine, you mill one side and the other side. You will have a different finish because one side is client milling and the other side is conventional milling. You flip the part one time and you can do the other 2 sides. If you have a nice big shaper, you put this part horizontal, flat in the vise. The tool 45 degrees and this little angle here, you can cut it in 1 pass. 1 stroke, not even 1 second. Chuck, chuck, finished. Make this taper on a small milling machine. You're gonna dial in a little bit, take a cut, dial in a bit more, take a cut, dial in more, take a cut. That's gonna take a long time. If you have a nice big shaper machine, you dial in all depth, 1 cut, not even 1 minute, face is finished. So I hope Mr. Pete will not be offended while he's watching this video, because it's absolutely not the purpose. So there's no need for Mr. Pete to come over here and burn my house down for it. It's just a video where I show that shapers are not slow. It depends how you use them.